Hello, I'm Stephen Foskett from Gestalt IT and Tech Field Day. Welcome to the Brocade Virtual Symposium. We're here with a number of folks from various network blogs, independent writers, speakers, bloggers, that sort of thing. And we're talking to Chip Copper from Brocade about basically what Brocade is doing in storage and networking. So we're going to have a few videos here that we're going to record. We're going to post them all together, and you'll be able to watch various topics. So let's start with some introductions. I guess I'll start first. Let's start with you, Brandon.
Hi, I'm Brandon Carroll, and at Twitter you can find me at Brandon Carroll, and my blog is brandonjcarroll.com.
I'm sensing a theme.
All right. Hi, I'm Chip Copper. I'm at chip@brocade.com.
And I'm Greg Ferro. I'm a blogger at Ethereal Mind, and I record a podcast called Packet Pushers, which hopefully you've heard of, or I'll be disappointed.
Ivan Pepelnjak. You can find me at ipspace.net and on Twitter at iOS.
Ethan Banks. I'm a blogger at packetpushers.net, and I also am a host at Packet Pushers and the Packet Pushers podcast.
And as Greg mentioned, the Packet Pushers podcast and the Tech Field Day website are great places to find all sorts of content like this. We've got a lot of really good technical discussions about networking, storage, virtualization, and so I highly recommend that you check out the Packet Pushers podcast and techfieldday.com. So let's turn it over to you, Chip.
Sure.
Why don't you introduce what we're talking about here today and maybe go into some of the details?
Sure. Well, a lot of times when we get into discussions like this, people talk about fabrics like they're new things. Like everyone's excited to find out what a fabric is and where they came from. And basically, the idea here is that fabrics have been around for a decade and a half. So we're going on 15 years of experience with these things now, which also means we have a lot of experience with them. We know how they behave. We know what they're going to do. And the thing that's interesting about this is the motivation here is to consider a decade and a half old technology over technology that's 40 years old, because we find ourselves in an environment where we've always done it that way before. For example, looking at the slide, you can see that this is a diagram that when I was just a pup cutting my teeth in networking back in the 70s, we had exactly the same diagram. The idea is that we're going to take cheap, dumb devices and we're going to put them at the edge. And then we're going to take a little bit more expensive devices that do a little bit more, and we're going to move them a little bit further up the hierarchy. And then we're going to get a few really expensive devices and put them up at the very top. And what happened is during the 70s, we did that because of constraints. And actually, this carries with it a lot of legacy that came from the Aloha network that was on the Hawaiian Islands. And we found ourselves making some really dumb rules about the way Ethernet Layer 2 networks should work. Not because it was best practice, but just because we didn't want to go to the effort to re-engineer things. And so, for example, we have to worry about things like loops. Now, why do we have to worry about loops? And the answer is because when we implemented the Aloha network, it was a broadcast that was actually taking place between these islands, and so we didn't have to worry about packets making it all the way around the world because the transmitters weren't powerful enough. And so what we did is we said, well, you don't have to worry about loop detection, you don't have to worry about hops. So when we changed the medium from being the ether, the air, we actually made it wires. We said, well, we have to have the same constraints. We don't want to have any loops in this thing. And so we start coming up with silly rules. For example, you have to lay these things out in the form of a tree. And the reason it has to be in a tree is because otherwise we're going to have these packets that keep going around in loops. Now, people may not remember this, but again, when I was a networking engineer, my job at 5 o'clock was to walk out to our network, and it would be 70, 80% active.
And you'd have to clean up the tokens, right? You'd have to sweep them up?
That's exactly what I had to do. I had to walk up and I had to unplug a MAU, and then I would watch the network traffic go from 70 to 80% to 0, plug it back in, and I'm ready for the next day. That's exactly what I had to do.
I always used an Ethernet to capture tokens.
Exactly, an Ethernet is a great way
It's a great way to keep the tokens under control.
Perfect. We need like a token magnet or something. Right? So when we start getting into these hierarchies, we kept things exactly the way they've always been done before. So then here's what we figured. This is the 70s, which by the way is still the greatest time ever to grow up. There is no time ever better than the 70s. Okay? Well,
I think all of us at the table would agree with that.
Oh, it was great. As best I can remember. So what happened is, during the 80s, we figured they'd fix all these things because there's going to be a new generation of engineer that's going to come along and they're going to look at some of the problems that we had and they're going to fix it. But then the bad thing happened. The bad thing was that all of us went from being the people who ran the networks into being the people who designed the networks. And what we found out is if we go in and kind of change the way we're doing things at this point, all of a sudden we're not the experts anymore. So what that meant is through the 80s, we saw people tending to do exactly the same thing they always did before. And then during the 90s, the same thing. And so instead of going in and radically changing the networks, we kept things exactly as they were before. And so, but here was the thing. I mean, it's kind of insidious. It's kind of a little embarrassing to talk about, but maybe we should just talk about it here. The idea is that we didn't want to go in and drastically change things because that was the wrong answer on the tests, right? For example, if someone came in and they said, how are you going to design a network? The right answer was always, well, it looks exactly like the diagram that we see here. This is the kind of things you put here, and then there's a different kind of level that goes up there. And we all took those tests. And so in order for us to get the accreditation and the certification to show how smart we were, we put down exactly these same things. But we were uncomfortable. It's sort of like one of the family reunion things. There were some things we just didn't want to talk about. And so, for example, it became very popular to say things like, I don't like spanning tree. In fact, it's vogue today, right? Everyone says, I hate spanning tree. I hate spanning tree.
Say that.
But you know,
I think spanning tree is overdone. I think a lot of people hate spanning tree because they don't want to take the time to learn it. It's not that. It's a great protocol. It's served us well for 30
serves
years.
a specific purpose really well.
Yeah.
It
If
did.
you have the right network design, it actually behaves well.
Yeah.
that's exactly
And
right.
if you keep things under control, you don't have a problem with it.
Yeah.
If you know what you're doing, you can make it work.
That's right.
The problem is that people don't spend the time to learn how
or
to
to
do
have
it properly.
control,
Yeah.
or to understand what
They just plug things together and then they're surprised.
Yes. But it's vogue to hate it today,
Yes,
right? I mean,
absolutely.
walk into any data center and people are going to tell you, oh, we don't want spanning tree, we want to get rid of it. And so what we've done, again, going back to these traditions, is we've started doing things so that we can still have them, and we can have them behave badly, but we can feel better about it. For example, instead of one spanning tree, I'm going to have multiple spanning trees. And instead of slowly converging spanning trees, I'm going to have rapidly converging spanning trees. And here's the latest thing. This is the latest technology. I don't want to admit that I have a spanning tree. And so what I'm going to do instead is I'm still going to have a tree, but I want to split nodes, and then I'm going to use some sort of proprietary protocol to allow those two nodes to talk to each other so they look like one node. So now I have a spanning tree without looking like a spanning tree.
I wonder who's doing that.
It's nuts. I mean, who on earth would be thinking about
Who would
that?
ever be doing that?
Yes,
Yeah.
I imagine.
That's crazy. But we're doing it. So we are desperately trying to cling to spanning tree. I mean, and it's time that we face that. Well, about a decade and a half, by the way, I'm a West Virginian. And as a West Virginian, I can't give you the short answer. I got to tell you the story. Okay, so bear with me here as I sort of work through this, because now I've gone from 40 years to 15 years ago. 15 years ago, there were a bunch of people who came up with this radical idea. And the radical idea was, I want to put a network between my storage device and the CPU. This is the third time I'd seen something that was this radical. I'd gone through a couple other generations of this. For example, I remember being in a room where someone said, let me get this straight. You're thinking about sticking this controller, what do you call it, a RAID controller? You want to put a RAID controller between my CPU and my disk drives that's going to be spraying data out across all these different drives so I don't even have a single volume? That's nuts. And in fact, I even had people who told me, there's no way I'm ever going to allow a RAID controller to come into my environment. It's not going to happen.
Those people are called DBAs.
That's right. That's right. But today, look at that. And 15 years ago, there were people who said there's no way I'm going to put a network between these two because it's not, if anything goes wrong with storage, you don't get a chance to timeout and retransmit. The screen turns blue.
Funny enough, those people are also called DBAs.
Yeah, that's
I thought they were called storage.
Yeah.
So what happened is the networking people were sort of disenfranchised from that entire domain. And the people who took over the job of engineering these storage networks were the storage people. And so they said, forget all the stuff that's bad. We don't have to live with spanning tree because all those old guys from the 70s, they're not in this room right now. Let's redesign a network the way that we want it. For example, instead of having these trees and coming up with all these technologies to allow us to keep the trees, if I have two nodes that are next to each other, I want them to talk to each other. I don't want them to have to go up artificially. I don't want them to go down artificially. I just want them to be able to talk to each other. I think a side tree I'll get to this eventually. Trust me. But I think a side effect of this is I was in talking to a customer a while ago who's not a Brocade customer. And she came in, she actually owned some applications, and what she said is, I just have one question before we even consider Brocade networks. And depending on the answer you give me to this, we'll decide whether we can go forward. Okay, what's your question? She said, do your networks support subnets? Softball, right? So what did I say?
Yes.
Yes.
Yes, of course I do. And guess what she said to me? Here's the door. I would like you to leave.
Yeah.
And I thought, what an unusual thing to say. And so I said, why do you want me to leave? You know, what did I, validate parking something, give me something to walk out of here with. And she said, here's what I do. I don't know what subnets are. But all I know is that when I walk into my IT department and I say to them, I want to deploy some of my virtual machines here, and I want to deploy some here, and I want to move some over here, and I want to be able to move through and load balance and have vMotion take place and so forth. My IT people say to me, no, you can't do that. Well, why can't I do it? Well, because they're in the wrong subnet. Because they're in the wrong place. So she said, I have no idea what subnets are, but all I know is that subnets are preventing me from accomplishing my business goals. Look at that! I mean, that's embarrassing. As a network professional, that is embarrassing. That now we've stepped on the things. So, so what that means is we went in, we sat down, we talked about this, and she said, what I want is a networking infrastructure that allows me to put what I need, where I need it, when I need it there, and to be able to recoup. And so I had the storage person at the time say, how do we do that on the storage area network? How do we do that? And so the storage expert went through and said, here's how the fabric works on this side. Here's how you can put things wherever you need them. Here's how you can scale up. Here's how you can scale down. And she said, that's what I want on the application side. I don't want to have, she said, and if you can let me do that, I don't care whether you have subnets or not.
Can I jump in?
Sure, sure.
Because you've touched a number of my sore spots.
Oh, good.
I totally agree with you. There are two problems that have to be mentioned to be fair to those people who were doing things right. Number one, we can do the same thing that storage can do in networking if we go from bridging to routing. So if we would throw out Ethernet as the end-to-end medium with bridging, and we would say we will route on the 4 bytes that's called IP address on every hop, which is what storage is
Layer
doing.
3 is all about.
Then that lady wouldn't have her problem.
That's right.
And we are just either too blind or too lazy or too driven by marketing departments of various vendors to realize that this is the way to go.
Or we've always done it that way before. And don't
Yes.
underestimate that, because that's what all the experts are going to tell you. You want
Yeah,
to go.
there were a lot of PhDs written on that topic.
That's right.
So yes, I totally agree with you, but we have the same solution in the networking side as well. We were just ignoring it for the last 15 years.
Yeah. And Fibre Channel is layer 3 protocol, layer 4
Exactly.
protocol. I mean,
Sure.
You know,
Yeah.
Fibre Channel is a much higher level protocol, which is why
Fibre
it can
Channel
do a
is
lot of these
actually
things in
routing.
storage. Yeah, exactly.
Every FCF is a router. That's why it works so
Yeah.
well.
But it doesn't need to be this way. And so what that means is that we sort of have to go over and look at the people who've done this work with fabrics and say to them, what worked? How can we get the efficiencies? How do we get the scalability, the low latency? How do we bring these over into the Ethernet world? Because I think the cold reality is Ethernet's not going away for a while. And I absolutely agree with what you're saying in principle. And in fact, we have some fascinating architectural discussions with people who are actually looking at moving layer 3 all the way out to the edge.
Yeah,
And-
where it should be.
And they're very successful at that as an alternative. And so what I'd like to offer here is, let me see, how much time did I spend on slide 1?
Yeah, you.
And the bad news is I'm only halfway through slide 1.
Now,
But it
so
was
when you
great
said with just a
history,
few
thank you.
slides, what you
Yeah,
didn't
but-
say is each one's 15 minutes a slide.
Exactly.
Okay.
So go ahead and if you would advance that.
Advance.
By the way, there's some motion going on in these slides. If you get it all disoriented, just close your eyes until the vertigo goes away. You'll be back at the normal.
And then there's some audio too that goes, LOL!
The thing that's interesting about this is you'll notice that the supposition here is that we can take that rigid hierarchy that was determined not by the business needs, but rather by the networking people, and we can make that more amorphous. We can make that a cloud. Now, here's the thing. Inside of that cloud, you can have whatever you need it to be. It may be a mesh. It may be exactly the same two-tier hierarchy that we saw before. It could be a cube, it could be a hypercube, it could be a ring, it can be whatever you want it to. The point is that now suddenly building a network doesn't become dependent on what's on the test. The way that you build a network depends on what are the applications you want to run and how do you want to deploy these applications. And so that means from the viewpoint of the edge, I don't know what's inside of this cloud. And I have to say this cautiously, that doesn't mean you just go in and hook a bunch of stuff together. We have, again, I'm going to digress for just a second if you don't mind on this. One of the things that's really fascinating is we have a tool that we use on the SAN Fabric side called SAN Health. And SAN Health is a free tool. Anyone who wants to can run it, not only on our fabrics, but you can run it on other vendors' fabrics as well. And one of the tools that comes out of this is a topology map. The topology map will show you exactly what the connections are between all these different nodes. Now, the thing that's interesting about this is whenever we run this topology map, we get it printed out, we'll take it someplace and have it laminated and put our name on it and so forth, and we take it in. Invariably, we'll have a network administrator who will say, why is that link over here? Or where did that link come from? Now, some of these links would be absolutely devastating if we were allow them to go into an environment where we were running traditional protocols like spanning tree and so forth, and yet in these fabrics, they work just fine. Because there's intelligence that's inside of this fabric that's been able to figure out what's going on and can still use that link effectively. And when you've got something going on in your data center, I need more storage now, I just lost a cable, I lost a port, I need something, and I need to switch things down, that's not the time to be going, wait, let me examine what I have because I don't want to violate these rules, because if I do, the network stops working. Instead of that, you have the network that adapts to what's going on, and so this does become much more cloud-like. But again, the point I want to make here is that doesn't mean there's not a right way to do it. There is, and there's.
But this
fabric
is not an application cloud. It's not an infrastructure as a service cloud. This is a networking cloud, in the sense that
It's a classical Visio cloud.
yeah, the
It's
WAN.
network as a service cloud.
Yeah, the network services cloud.
Yeah, you know, a network
Which
is a
is
service
what
cloud.
it's supposed to be.
Yeah.
It can be, but more and more we're seeing, for example, people are coming along and they're saying, I don't want to have a generic infrastructure. I want to have VDI networking, or I want to have virtual machine networking, or I want to have this other kind of networking. And so in that respect, it very much becomes an application-oriented.
So we want to take away, so one of the things I made a note down here was, today, Spanning Tree creates arbitrary design limits. So we have to have a specified route, and we have to have specified pathways as we track away to the edge.
That's
and
right.
the way we do that, to just paint that reverse picture, is that we have a core, then we create a distribution layer, then the distribution layer has the access, and then there's these spines that radiate out from the core, so bang, 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 and that is enforced design rules. And this creates invariant design principles where we say, this switch must plug in here and it must home back to the two cores in the distribution. The distribution layer must plug to the access, and the two switches here plug back to here, and then we have the nice little box or the triangle or the inverted cube, or whatever you want to call it, right? But those are enforced principles because of the nature of the spanning tree protocol.
That's right.
They're not something that we as users would choose to implement, right? And so this cloud represents that abstraction away from spanning tree. If we could move to a protocol which didn't create invariant design points, which says this is mandatory, you don't get a choice, you have to take it.
Actually, if we could move to routing.
Yeah.
Well, and this is the benefit of layer
Yeah.
3 rooted cores, is that you can have many paths from a given point to a destination, and there's only one path for any given flow or any given packet.
Which is how the internet works.
Yes.
I mean, the internet is not a core edge design.
Exactly.
Well, it sort of is, but it, yeah.
So, the point here is that the spanning tree protocol that we use today for layer 2 solves the problem of loops because of Ethernet's inherent limitations. It has no TTL. So when you inject an Ethernet packet into your network, there's no time to live, and which decrements as it moves across the network. So an Ethernet packet can live forever. So if it gets looped around, then it causes problems in the network. So
Which is the fundamental problem with Ethernet.
fundamental
right there.
problem with Ethernet. It was built in a time when that wasn't a consideration.
Exactly.
Sorry.
I mean, even
To be a
bridging
bit
didn't
Ivan
exist.
about that,
Yeah.
Ethernet is a layer 2 protocol, and layer 2 protocol was always meant to be between two adjacent devices.
Yes, that's right.
Yes, because it was
And-
designed without even bridging in mind, without
Yes.
routing in mind. I mean,
Yeah,
it was
that's right.
designed.
And Ethernet was designed to be run on a coax cable.
Broadcast.
And when they introduced bridges, they effectively broke the layering.
Yeah. So what was
A thing that was supposed to be used between adjacent nodes was all of a sudden used across a networking device, or you lose visibility. So they broke the layering, they broke the architecture, and we are living with that problem for the last 30
That's right.
years.
And we haven't fixed it. You're exactly
Exactly.
right.
That's right.
You're exactly right.
And so this is to summarise that, that is part of the problem. Is spanning tree creates these arbitrary design points where we have to be enforced into those, but we don't want to be if we could not. So aside from the fact that spanning tree has a price tag, which is what I call it, we put spanning tree in, but people will attach a value to removing it because of those invariant designs. So because we have to have the tree, people say I don't want a tree. It doesn't meet what I want it to do. So there's a price tag attached to taking spanning tree out of your network, and customers are willing to pay that, which I think is sort of an interesting point, because we've never challenged in networking the validity of whether spanning tree is a question. Spanning tree has always been the answer,
That's right.
right? So
Well,
we've always
it was
had.
fact of life.
Yeah,
That's
you
right.
have to deal with it.
Yeah, it's always been. You don't get to question whether spanning tree is the answer, and making it faster has taken away some of the pain points, but it hasn't solved the underlying point. And just one final point I wanted to make about this is that
Certainly.
what you're driving to here is, in the previous set we talked about the 3-layer hierarchy. So we've always in Ethernet networking, and certainly in layer 3 networking as well, but in layer 2 networking, we've always decided to have a core, a distribution and an access, because
Right.
it helps to solves the problem of various bandwidth concerns. We'll talk more about that when we get to the thing. But fabric architectures that we're talking about here actually move us to a 2-layer model, where we have core and access, and there's no requirement for most networks to have a distribution layer.
That's right.
Yep.
Yeah, and it's
that's-
important to realize too that fiber channel fabrics are hierarchical. You do have core, and you do have edge. You just don't have quite the same kind of hierarchy that you have in Ethernet. It's not like
Not all environments. It turns out that in many environments, that's not the case. There are rings, there are meshes, there are some other environments that go on. For example, shameless plug, right?
Yeah.
Brocade. It turns out that with our largest chassis now, we're using these inter-chassis links, and the idea is that we'll actually create a mesh of 9 of these 384 port devices, precisely because they don't want a core edge design.
But practically speaking, you're going to put, a top of rack fiber channel switch. You're not going to put your Brocade, massive directors all over the data center.
So it depends on the deployment, because if I get into an environment where, and this is where we were on thin ice for a while, but it seemed to gain a lot of acceptance, there's this concept that says chassis versus small form factor. If I have a fabric, and I can do the right layer of abstraction that we'll get to here in just a second, if I can do that, I don't need that big chassis anymore. If that big chassis isn't going to give me any more functionality than I would otherwise have by putting together all those smaller boxes. So once again, I would say that those architectures, like the distribution and so forth, are being caused as a side effect of this rule that also goes into saying the less expensive, less capable boxes go at the edge, and the more capable boxes go at the core. And I think that fabric people in the SAN have rejected that.
Well, actually, the layering and the number of tiers in the network, that's just the marketing play used against a certain 5-letter vendor. Why do we have 3 layers like you've shown? Because we didn't have high performance, low cost, high port count switches. So we were forced to aggregate on 2 layers because we couldn't attach all the edge to the core directly, because the core switches were not performant enough and they didn't have enough port count.
And they were expensive.
Yes, well, on top of everything else. So once you have the huge switches that almost every second vendor has today, you can get away with the middle layer because you just don't need it anymore because the port count on the core switches is big enough. Like you said, you have 380 something ports on a switch. Obviously, you don't need a 3-layer design with that switch because no one will have 20,000 ports in a fabric.
It's possible.
We do. We do.
Oh, yeah, okay, 100,000.
And for sufficiently large end.
Do I have 150, 150, 150, 150, 160, 160, 160? Sorry.
And I think too that an edge fiber channel switch is not analogous to an edge Ethernet switch or a top of rack Ethernet
Bingo.
switch. They're much better devices. And again, I'm the storage guy, so I want to kind of point this out in terms of intelligence, in terms of buffering, in terms of a lot of things.
Okay, can I take that?
You can take that.
You're absolutely right, but that's only because the storage vendors were forced to do it that way because the fiber channel protocol stack doesn't have bridging. So they had to do it right. They had to put
They had to do it right. Wait, can I hear that again?
Let me take that a different way. Because the fiber channel protocol specified that loss could not occur, that mandated that the switches had to be
Smart enough.
to cope with that fact. And that meant that it had to have expensive fibre optic cable and expensive transceivers and expensive switches that couldn't drop a frame. So by just sitting there and saying, la, 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 don't drop a packet, that meant the network had to compensate. Whereas Ethernet networking said, we can take a lower cost, more practical approach and accept packet loss and let the applications recover. And so we were able to make cheaper switches. But in the same time, we drove networking down to the lowest common denominator. So people could employ cheap and dumb devices and get a second-rate network.
Cheap
Yes.
and dumb.
And that's,
Yes.
and that's the way
and
the
then
market
it's the
chose.
network's fault. It was
That is-
never the fault of the guy who didn't approve the budget.
No, that's right.
Right.
Whereas Fibre Channel mandated this overdriven, overworked, and it's worked very well for
You can
storage
say
people.
awesome anytime you want.
Over awesome. How's about it?
Is it too late to switch chairs? So let me offer a different perspective. You're absolutely right, but let me offer a different perspective of why we saw this intelligence the way we did before. When we first came out with this idea of putting a network between the storage and the CPUs, everyone said, no way. Some cowboy's going to have to come in and do that because I'm not doing it. The reason we came out with the small form factor switch first was because it was 5 hosts going to 2 storage arrays.
Yes.
That was a storage area network. So what that meant is we didn't have a chance to build this hierarchy. That little box had to do everything. Mm-hmm. It had to do everything by necessity. And they were more expensive and they were more complex. But it gave us an enabling technology because once again, if we put that box in there and it didn't have that intelligence and things were turning blue, storage area network would be something of the past. I mean, we'd be sitting here talking about something else today because it would have no history for it. So it sort of built organically, it very definitely grew with a collection of these smaller boxes. And then after the SANs became large enough, then we had critical mass to combine those into the large chassis. So in the SAN, the small switch came first. Yeah, and you know, we did kind of do that, I guess, with local area networks, where a work group didn't go to the outside world. All I need to do is talk to my printer.
You mean the novel networks that were connected then to the IBM host?
Yeah, yeah, exactly. Yeah. So let's go ahead here. I'm now going officially to slide 2.
Oh,
So are we good? Are we good? Did I lose anybody?
Golf clap.
A couple comments on this diagram before we get into it. The first thing I want to tell you about the diagram is you notice that I have 6 nodes that are up there. The reason that there's 6 nodes is there used to be 5 nodes that I was going to show you, and actually we'll go to that in just a second, until one of my competitors pointed out, in fact, that my network looked like an inverted pentagram. And that's exactly right. And so if you don't want satanic things inside of it, you'll never consider this type of fabric. So now there's 6 there, so you're that person. We fixed it. Yeah. The second thing I want to point out here is please realize that you're probably looking at this and saying, how come I have 2 paths and one is going through 4 nodes and the other is only going through 2 nodes? That's just the magic of illustration, and we're going to assume for the time being that's equal cost multipath, that we've actually got some other things in there that they're both equal size. So the idea behind this is that now you'll notice that we have a mesh, but the most important thing about this mesh is that we're actually using all the links, and we're using all the links intelligently. So that, for example, if I do have a virtual machine and I go out onto this fabric, I'm going to be able to talk to whatever storage device I need. There's another subtlety in here that I want to talk about for just a second, and this I'm going to go way out of scope for just a few seconds. You'll notice that at the bottom we have 3 different types of storage that are out here, NAS, iSCSI, and FCOE. The reason that we're showing this is in this fashion, rather than talking to other hosts, is not because the idea of this is limited to the storage domain, but because right now, if we happen to get into a room where there are storage people and there are networking people, non-storage networking people, the storage people are going to look at that diagram and say, oh, I understand what's going on. Kind of interesting to hear how in a lot of conversations, the SAN professionals aren't invited when they're going to be talking about networking issues. They're sort of like sent out of the room politely or something like that. And we're the networking people, we're going to set everything up, and then you're going to get what's left. And there's a lot of friction that's going on right now, by the way, because people are engineering networks that are expected to haul storage traffic, and they're doing that independently of the storage teams. And so now the storage teams are coming in and saying, you've broken my service level agreement. I quit. You know, I can't do this anymore if you don't give me end to end. So although it's showing hosts going out to storage, those could just as easily be communications that are taking place between the different virtual machines that are out there. The other point that I think I want to make here before I actually get to what the intent of the slide is is that at the bottom you'll notice there's a lot of different storage mechanisms that are built out there. The idea of a fabric is you want to deploy it once. For example, we have a lot of customers who at the time they're deploying these new data centers, they don't know if it's going to be going off of installed fiber channel base, or if it's going to be fiber channel over Ethernet or iSCSI, or if it's going to be NAS. They don't know. And so the idea is that, well, if we build the network right, it can support whatever kind of traffic you need to have to support storage and peer-to-peer communication with whatever rules you want those things to go into. So just a couple notes, now I can get to the slide. The thing that you notice here is that there's, and I think this is a big difference, intelligence. That, if I might, I'm going to digress again because I think this is relevant to the point of intelligence. There have been several environments where there will be one dominant network player in place. And another network player will come in and say, hey, I want to sell you Ethernet switches. I want to sell you my competing product. And the answer that you get from the networking people is, hey, we'd love to have you in here. We love your product. Your price point is great, but we can't do it. Well, why not? Because all of our scripts are written for this one particular operating system, for this one particular command line. And you say, well, how many of these scripts can you have? Like, oh, you would not believe. And this is where the number probably usually gets artificially inflated, where they'll say, I've got tens of thousands of lines, and I can't bring this in. Isn't that a little bit embarrassing? Let's think about what that investment in those scripts really says. What that says is that, and I say this respectfully to switches, because we make switches that do this, so I'm not saying anything, I'm looking in a mirror here, it's not comfortable, but I'm trying. I might be coughing something up here too, but in a few minutes if you give me a second.
I got your back.
Yeah, you got my back, excellent. But what we see here is that we've always done these things where we expect the switches to be dumb, I should say. We want to have switches so that in order to get the switch to have the behavior that I want, I have to run all these elaborate switches. And so if you have this massive investment of all these procedures that you have to run even to deploy the first switch, what that basically says is that you're transferring to humans the responsibility for running these networks rather than say, let's move the intelligence into the network. Yes, sir.
Totally agree with you, but I have a totally different reasoning how we came to that place.
Oh, let's hear it.
The problem is that no vendor is ever willing to say to a customer, enough. I will not implement your feature, even though you're buying for $50 million worth of equipment. The problem why we need all those scripts is because we can't agree on what the best practice is. We can't agree on how to configure a switchboard. We can't agree on how to configure a routed port. So the vendors can't implement the default behavior that would make sense to at least two of their customers at the same time. So they give you all these knobs and features, and you can configure zillion different things so that you could run your network the way it has been run for the last 30 years when it was designed by who knows who.
Right.
Because no one is ever willing to say, this does not make sense. Dear Mr. Customer, please go away. Redesign your network and then we can talk.
I think we should rename the term best practice to best opinion. It's really what it boils down to, because that's where they all stem
Yeah,
from. This
and
opinion,
I'm really amazed how well the Fabric implementations are holding up so far. Because your implementation is pretty simplistic from the outside.
That's right.
Ethernet fabric or fiber channel fabric?
Yes.
Ethernet Fabric.
Yes.
Okay.
Yeah. Yes.
Yes. Same thing.
Yeah. Cisco's implementation is, at this moment, pretty simplistic. We know it runs ISIS internally. We know there are a lot of moving parts behind the scenes. But yet again, you configure it with two commands. I'm positive there will be customers jumping up and down and asking for a zillion additional features. And I'm positive that both solutions will eventually get polluted and we'll be back to 10,000 line scripts because the customers will be asking for all those features and you'll be implementing them. I just hope that this time you guys will be able to say no.
Well, the good news on that, again, is with 15 years of experience on the fiber channel side, we have said yes and we have said no, but I would venture to say that one of the reasons that we're seeing a need for those additional commands or those configurations is because people have to do it manually. If the network is just taking care of it, like for example, if you talk to a networking person today, everyone has some sort of sniffer on their on their laptop, right? If you want to know what's going on, you go in and sniff the network. This is 2012. Do I really need to understand how a protocol works by putting a sniffer on a wire? I mean, it's fun in a hotel room to see what kind of traffic is going on. And Brocade is not advocating anyone doing anything in their hotel room to sniff to see what else is going on.
Not that I've ever done that.
Yeah, no, of course not. No, I'm confident none of us have ever done here. But the point here is that we put people in those situations where they have to make those decisions. Think about Network Operations Center. A lot of times when you're touring at a company site, they'll say, look at my Network Operations Center. And what are they? They're beautiful. They've got
totally useless.
They've got high definition screens up on the walls. They've got ergonomic chairs. They've got 3 or 4 screens. You know why the company is going to all that expense? It's because they have to. They have to keep that network up and running, because if they don't put that investment in it, which could just as easily go into their product instead of the network, it doesn't work. Now let's think about a storage area network infrastructure. Where is the SAN knock? Right? Because remember that in this environment, if anything goes wrong, all those virtual machines die. Where is the SAN knock? And the answer is, well, let's go down to Bob's cube. Bob's going to bring up a virtual desk on some server that they begrudgingly put in a data center somewhere, and here's this little cube. Now let me get this straight. You need all these people with all these HD screens to keep the regular network running, but if we bring up this little screen in Bob's cube, this is how my SAN is running, and if anything goes wrong on that SAN fabric, if it's late, out of order, duplicated, incorrectly configured, things blue screen. What's the difference?
It's a little bit. So networks are a little bit more diverse than a SAN. So a SAN is a single-purpose network.
Yes.
So, for example, if I built an Ethernet network that was just for data center technologies that only ran web traffic, and that was all it did, and for one application, for one client to one server, then it would look like a SAN. A SAN is a single-purpose, single-function. Storage traffic traverses from a client to a server, so it doesn't have the complexity of an Ethernet network. There are divergent.
And I think it's safe to say that when we have converged networking and storage, we will still have network operation centers.
Yes.
Well, the other thing is that actually when you start, they show you that beautiful knock. And if you're talking to the right people, then they will probably say, and by the way, we as the networking team, we don't use that because it's totally useless. Here's the SolarWinds we have, and it actually gives us the stats we need.
Yeah.
We have that beautiful thing just to show to the customers and to have the support system running where people can report that printer has jammed.
And Google Glass House, yes.
Yeah.
But yeah, I mean, networking is ultimately not just about storage. Although storage is a vital part of any networking strategy, you know, data networking itself is, and networking is a far more diverse market than just. So our data centers don't just run Ethernet storage data; they also run voice, video, applications, clustering, multicast, load balancers, and provide a whole range of services that are, and that's what makes networking hard.
So you're absolutely right with the focus on the storage environment here, but I would still argue that there are some benefits to say, let's look at the way that, now forget the application, let's look at the fabric nature of it.
Absolutely, yeah.
And that's the piece that we need to bring over, because I certainly would make the position that said fabrics aren't going to make it worse.
No.
Through the automation of policies of things that are going better, and by putting additional intelligence into the network, I believe the situation is going to get much better.
Yes.
So that things can become much more proactive. So, for example,
Let's get there.
so for example, if you hit the space bar, you notice that if something goes away, the network just reacts. And this happens all the time in the same environment. Something goes down, and similarly, if you advance it again.
It happens all the same way in routed networks.
Yeah.
So you're selling us internet now.
But you know what? This is a hard sell. I mean, realize that. I mean, right? Because if you go in and talk to most people who are doing layer 2 today, they might agree with you and say, yep, and we're deploying network, and we're deploying spanning tree, and we're going to do it exactly the same way that we've always done before.
Yeah.
I mean, so
Good luck with that.
Yeah, everyone agrees with it. In fact, it's a little discouraging again, because I'll go in and I'll talk to a lot of people and say, tell me what you're doing for your next generation data center. It's exactly the same thing we did 40 years ago. Exactly the same thing.
Yeah.
And going into something like this is a lot less comfortable. So we get the idea here that it's going to be automatic, that people are notified about what happened rather than having things forced. Let's go on to the next slide here. So this is another uncomfortable slide. Let me kind of tell you what's going on here and tell you why this is uncomfortable. there have been times I've gone in and I've had conversations with people about the intelligence that's going into a fabric and talk about the fact that I have a friend, by the way, whose livelihood is setting access control lists in a very large trading house. And he's paid very well. I mean, he gets a ton of money. But from 8 in the morning until 5 at night, all he does is manage these access control lists. And you know what? He hates his job. He loathes his job. But guess what? You know why he keeps doing his job? Because they pay him a ton of money, right? I mean, he likes paying his mortgage and all these different kinds of things. And invariably, when you start talking about what the network can do because of the automation, because of the intelligence of the fabric, his first comment after understanding the technology is, you're trying to put me out of a job. That's a very real element here. Because once again, what it comes back to is once we get to the point where we see these things start to become intelligent enough that they can start to manage themselves, then we don't have to have as many people doing this. Now, I'm not saying get rid of people. I'm saying redeploy them to other things, especially as cloud architectures and services start coming along. That would be, I think that the role of the IT administrator is going to change, to talk more about how we're going to manage those types of infrastructures. But again, out of scope, different topic. What I'm going to show you here is yet another case where when people say this, they'll say, you're trying to put me out of a job. And the answer is, I'm just trying to make your job more interesting so that you can go do something else. So we're going to take the typical case here. Suppose that I have a virtual machine that lives on a particular node. And I'm going to briefly talk. I think we may talk about this in a different section later. But we have to get on something that's ugly. For example, if I have 2 virtual machines on the same node that want to talk to each other, this is the classic, if you can't fix it, feature it discussion. Because how do those 2 things talk to each other? Well, the way those 2 things are going to talk to each other is they're going to go out to the network, and the network's going to hairpin and come back and give it the message, right? No, that's not what's going to happen. Well, why can't you hairpin? Because 40 years ago, when we made Ethernet switches, we said you can't transmit something out of the same port that it comes into. And so as a standard, we said you're not allowed to send something back out. So now if 2 virtual machines on the same ESX server are going to work, what do we have to do? We have to add a layer of software switching into the middle of this thing. That's a perfect if you can't fix it, feature it. In other words, because networking is broken the way we've always done it before, let's add another layer of networking that's in there. Well, now who's going to manage that other layer of networking? Well, the networking people don't want it because it's another thing for them to manage and it's on another switch. The hypervisor people don't want it because they're not networking people, they're hypervisor people. But there was a side effect that came out of it, and here's what the hypervisor people saw. This was fun. They said, hey, if we use these soft switches, and I have 2 of these virtual machines that live on the same node, I can configure these things without opening a help ticket to the networking group. This is cool because these networking people take forever. They get the wrong configurations. They're not responsive.
It's just terrible as networking people.
But
let's talk about storage, people.
There's actually 2 parts to that.
Yes,
So
please.
you configure a virtual port. There's no feedback from the network to the virtual client server to say what's being happening.
Yes.
And there's no feedback from the server to the network to say what the server wants.
You're right.
Right? So as much as it's difficult for the networking people to get the intention from the server people, it's difficult for the server people to tell their intention to the network.
You're right.
So it's a little bit more sophisticated than just raising a ticket and the networking guys are grumpy to the server admins. It's also about the fact that the technological challenge isn't meeting the expectations of either party.
That's exactly right. And difficult is the right word to use here. It's hard to do.
Yeah.
And I don't mind the reason it's hard. All I recognize at this point is the fact that it is hard.
Yep.
So I absolutely agree with you. So now, what do we do about this? How do we try to make things more responsive? There's a tendency now. There's a new generation. We're the old guys, right? There's an understanding that comes along where the millennialists now expect immediate gratification. So the idea that says that if I'm going to deploy a new
Kids
virtual
these days.
machine, can you believe it? Go figure. So if we deploy something, I don't want to wait around for this thing to get configured. I want to do it immediately. I just want this thing to come along, and I can only get so many virtual machines, so now I gotta talk to these networking people. I have to let them understand what I want, and the networking people have to go back and forth, to your point, precisely. How do we do that? The argument that we're making here is that since we've got intelligent networks that sit into the middle here, you notice out here we've got a tool called Brocade Network Advisor, here talking about the fact that this is going to be network functionality. What we can do, and we'll be talking about this more later through a technology called AMP, the idea is that we're going to tell the network, here's a port profile. The port profile describes what the network should look like for a virtual machine coming off of a hypervisor. Whether or not it comes off of that hypervisor is a different discussion, and we'll defer that. But if, assuming it's going to come off of the hypervisor and it's going to go into the network, what should the network do when it sees these things? And so we define these port profiles. Through, I'll go ahead and advance it one more time, if I remember this animation right. And that profile that's been defined is going to be propagated throughout the entire network. So the network, once again, is going to behave like a single entity, and everyone is going to know this is a port profile. We then go through a process through vCenter, as you can see here, that's a form of activation. What the activation says is that vCenter is going to assign a MAC address to a virtual machine, and vCenter is going to assign a particular port profile back to this particular virtual machine or this MAC address as well. So what that means is that now the hypervisor administrator sees, I've got these virtual machines, they all belong to this class. This is my web server, these are my database engines, these are my analytics engines. They all belong to that class, so what the hypervisor administrator can say is, I just created a new virtual machine, here's its MAC address, I want you to assign it to the network. Now what happens is the first time that person fires up that virtual machine and the first few frames that come out of there, the network, an intelligent network, a fabric, is going to say, hey, new MAC address. What do I do with this thing? MAC address, oh wait, there's a mapping of that MAC address into this port profile. I'm going to go through, I'm going to configure the VLAN, I'm going to configure the quality of service, I'm going to configure the access control lists, all the other parameters that I need, and I'm going to do that instantly so that now that virtual machine comes online. What about spoofing? How do I authenticate that? The way that we authenticate that is that the intelligence in the fabric is communicating with the intelligence in vCenter via a secure protocol, standard interface. There's no like secret mystery sauce in here. We're using standard APIs to do that via SOAP. And we talk to them. We have vCenter validate, yep, I brought up that virtual machine, it's good. And now we've provided that service instantly. The networking people are notified the virtual machine came online, but they didn't have to touch a thing. And so now if that virtual machine happens to move to another node, once again, as soon as we see that new MAC address appear, we're talking to that instance of vCenter, hey, did you just fire this thing up? I did, and it's shut down here, it's consistent, it's who they say they are. Okay, then I'm going to configure the port and off we go. So once again, you'll notice through this configuration, the assignment of MAC addresses to port profiles, through the migration of VMware, there is no hands-on manipulation that needs to be done by the networking team. The networking team is notified of what happens. They're not out there servicing tickets to say what happens if I move this virtual machine that's over there. So once again, the idea here is that a networking person may look and say, you're trying to put me out of a job here. Because now my hypervisor administrator has the right to decide which of my virtual machines are going to go into which VLANs with which quality of service. And I'd say once again, probably what's happening is the network administrator takes more of a consultative role. For this particular class of application, for this particular collection of virtual machines, here's what the network should do. Let's set you up that profile. The application now drives the network. Yes, sir?
Actually, you're not driving, with this particular feature, you're not driving networking people out of their jobs. Because what happens in mid-sized environments is that usually they stopped talking, the server and the networking people stopped talking to each other years ago.
Because it was easy to do.
Yeah.
Not because they hate each other,
No,
but
because
just
that was
because the networking had a
quick-
demarc,
Yeah.
and the server had a demarc, and they didn't need to talk.
And so they
So
agreed
we actually
on
have to
a
re-establish.
VLAN range, and the networking people have just configured that VLAN range on all server ports, and they stopped caring. What you're actually doing here is you're bringing some of the control back. Not
To-
manually, to the network. Not manually, but at least the network starts behaving more intelligently. Because right now it's not flooding everything that everyone ever generated to every server who never needs that because the VM is not sitting there. Now the network actually knows where things are and how to deliver traffic to them intelligently.
That's right.
So one thing is, for the people who are watching in the audience, is that we are going to have a session later on today about the VMware network automation session. So if you'd like to know more about this, we're going to deep dive on this in the fourth session today, called Hard Cores and Soft Edges.
Yes.
So just note on that at this point.
Great. Let's advance to the next slide then and see what it has for us. Shameless plug. Have to show you the
We
product.
produce things.
Yeah, we make stuff. The reason I show this particular slide is because I'm invariably asked, when are you going to have this? When is this going to be available? When will you give this to me? Because Some vendors will say, we're going to have it soon. Some vendors have been talking about it for a couple years, haven't produced. Our solutions have been out and running as fabrics for almost 2 years now. So once again, it's a technology where it's out there and we're getting a feel for what's going to happen. And to your point, are people asking for more improvements? Actually, right now, we're seeing the biggest thing that people are asking us for is scalability. Because what they're saying is, we like what we're seeing, we like what we're using. The other point I want to make about here is, and this is, again, probably a topic in another session, but the majority of the deployments that we're seeing, this being made in today, have nothing to do with fiber channel over Ethernet. They're not fiber channel over Ethernet deployments. The reason people are using these is because they're realizing that the advantages of a fabric map just as easily into TCP/IP communications as they do in anything else. So that doesn't mean that this wouldn't work very well for fiber channel over Ethernet, and there are a few people who are dabbling with that, but the emphasis of this is certainly not we're going to replace, the onus for putting this in is storage traffic. It has nothing to do with storage traffic. It's regular TCP/IP traffic. And I think that that's the 4 slides I had for you today, sort of an introduction of what a fabric is. In summary, it's a topology that matches what you need that topology to be. It's intelligence that's being put back into the fabric. It's a fundamental management change that says now, I want to manage according to policies, so that the network is able to react to changing conditions rather than static configurations that say, this is what I want the network to look like now, and until I touch it again, it's going to remain exactly the same.
All right.